Continuing in Chapter 2, Section 2, Quadratic Functions. Here are the objectives. And first off, the standard form of the quadratic function. A quick review, this is the standard form of the quadratic equation. And this one we're calling the standard form of the quadratic function. I like to think of this too as the vertex form. And why so? Well, when you graph quadratic functions, they are a parabola that'll open downward or will open upward. Now, whether it opens downward or upward all depend on this value a here, which is this same a. If a is negative, it's going to open downward. If a is positive, it's going to open upward. And they're indicating that over here. Now, an interesting thing about this, the vertex, which is the highest point when a is negative, or the lowest point when a is positive, is given by the ordered pair h, comma, k. Aha, you might say, I remember that from the last section. That's a point in the center of the circle. Also, in this view, it's the vertex for what we also call the maximum, or the vertex in this case where we call the minimum. Now, what does that tell us? Well, if we go into the equation and pick out the value for h, and notice there's a negative sign. So let's give an example, and they're going to give examples too, but I like to do this repetition here. So here we say, let's say this is a 2. Okay, we've substituted a value for a, we substituted a value for h, we substituted a value for k. Now, what is our vertex then? Well, our k is straightforward, so whatever value is out here, that's going to be 4 in the ordered pair. Now, this is the tricky part because of this negative in the formula. Here we see it appears to be a -3, but it's not a -3. The h value is the opposite sign of this, so it would be a +3. Now, let's take this and put it into the formula. Well, if we put the 3 now into this formula, it's going to appear as a -3. Okay, so you have to be careful about the h value, while the k value is always what appears for k. No change of sign. All right, let's go on. Now, in graphing quadratic equations, there's a number of things we want to do. Again, from this particular form, which we're calling the vertex form. Remember, the vertex will be h, comma, k, which is an x, comma, y, and it's the opposite sign of what you see here for our h value. And we've already done this. Determine whether it's going to open upwards or downwards depending on the value of a. If a is negative, it's going to open downwards, and the vertex will be the maximum. If a is positive, it's going to open upwards, and the vertex will be the minimum. Determine the vertex of the parabola. And we've said that. That's the h value, the k value. Remember, opposite sign of h. Now, find any x and y intercepts by solving this equation. That is, if the parabola crosses the x-axis, that's where the y value is 0. We often describe this as finding the zeros. All right, we're also going to find the x-intercept by solving the equation when y is 0, what is the x value? And again, that's written as 0, comma b. The zeros here would be a, comma 0. And we often have two of them that they cross in two positions. And then plot the intercepts, the vertex, and additional points as necessary to get a smooth curve. Starting us off here, example 1, graph a quadratic function in standard form. Okay, there is the vertex form, we're calling it. What is our vertex? Well, there's our h value, opposite sign will be a 1, and our k value is the y, so our vertex is this. Now, is it opening upward or downward? Now remember, there's a -1 that we don't write here, so our a value is negative, so it's going to open downward, and there's our vertex, 1, comma 4. Okay. Now for example 2, we want to find the zeros. That is, where does this parabola cross the x-axis and where y is 0? So remember, we said we could substitute the function symbol with the letter y, and we're going to say this y is 0. So this is what I've written here, and I want to go to the whiteboard for this. And we want to erase this so we're not confused. So how do we solve this? Well, again, a variety of techniques, but I would suggest you take the 4, bring it over to this side, so this is now a positive 4. On that side, on this side becomes a -4. And this is x minus 1, the quantity squared. Now I could multiply both of these by a -1, and it changes both of these to plus. So that's what I'm going to do. And, when they are plus, we don't have the signs, so I'll just erase that. Now, one of the techniques for solving quadratic equations is the square root property, where I take the square root of this side, and again, there's a 2 there, so this just becomes the radicand, x minus 1. And I take the square root of this side, plus or minus the square root of 4, which is plus or minus 2. And I now solve for x by transposing this -1 over to this side as a positive 1. So I get plus or minus 2 plus 1. So I'm going to get two answers here. And I like to write it this way. So x is going to equal a plus 2 and a plus 1 is 3. Or x will equal a -2 and a plus 1 is a -1. So those are my x coordinates, but they are ordered pairs, where y is 0, one will be a -1 and the other will be a positive 3. Okay, I've worked it out for you, and you see it on this next slide too as we go back. And there they are. 0, a 3, comma 0, and a negative 1, 0. And that's where they got it from. Let me clear this up. And again, it's what we've done and hopefully helpful. Now we're continuing example, calling it 2a. It's all part of it. Here we want to find now the y-intercept. Where will the parabola cross the y-axis? Well, in that case, x is 0. Remember, this is going to be 0, comma b for the y-intercept. So x is 0. So we're going to put a 0 where the x is. So this becomes a negative 1 squared, which is a positive 1. But then that negative outside makes it a negative 1. Plus 4 gives me a y value of 3. So our ordered pair for the y-intercept is 3. So we're keeping track of all these values here because they're going to be needed to make our graph. We don't need a number of points. All right, let's go on. So we're calling this example 3. And now we're going to actually graph it from the points we've developed. So we know our vertex was a 1, 4. So over 1, up 4, there's that. We know our y-intercept was 0, comma 3. There it is. And we know our zeros, our x-intercepts. One was a negative 1, a 0, and then a 3, 0. So with these points, and when you put it into the software, it makes this nice curve. So again, our a value was a negative 1. Again, we don't see the 1 there, but it's there. And that indicated it opened downward. Now, there's one other thing we like to find. And you'll notice that when you haven't, let me clear this up here a little bit. When you find a parabola, that one side of it is going to look like the other side. And there's a line right there that divides the, and I can't make it too straight here, but it should be a straight line right down here. Now you might recall, what's the formula of a vertical straight line? Well, that was x equals a. And a is our x value of the vertex, which is 1. So this equation, which we call the axis of symmetry, is x equals our a value of the vertex, 1. So add that to your notes too. Now I briefly mentioned this in the beginning, that this is the standard form of the quadratic equation. Now if it's not in that vertex form that we mentioned, you can also use this form to find the vertex. And for this, we use what is called what I'm calling the vertex formula, which is negative b over 2a, which is what they're describing here. So let's look at an example. I think that's the best way to do this. And I think they're going over pretty much what we've gone over already. So I don't want this video to be too long. And perhaps an example is the best way to do it, so that's what we'll do. So we're calling this example 4, and the equation is in standard form. So let's write it. Y equals negative x squared plus 4x plus 1. Okay, and we're going to go to the whiteboard, and we want to find the vertex. So we say the vertex formula is a negative b over 2a. Well, let's define our values here. What is a? What's b? What's c? Well, a, we said, was going to be a negative 1. Our b value is 4. And our c value is a 1. Now, for the vertex, we don't really need the c, because it's only the letters b and a. So what is b? Well, b is 4, but we need a negative b. So it's going to be negative 4 over 2a. Well, what is a? A is a negative 1. So 2 times negative 1 is negative 2. So our x value then of the vertex, we can put it right here, is going to be 2. Now, what will our y value be? Well, if we know that x is 2, we just substitute the 2 into the equation on the right here, where our value is 2. So it's going to be negative 2, that's squared, plus 4 times 2, plus 1. So 2 squared is 4, but because of the negative sign, and remember it's sort of like a negative 1 up there, this becomes a negative 4. This is 8 plus 1. So this is 9 minus 4. Our y value is 5, and that's our vertex. Now, what would be our y-intercept? Where x is 0, we're looking for our y-intercept. Well, we go to the same equation now, but x is 0. So x squared is 0 squared is 0. 4 times 0 is 0, so y is a 1. So our y-intercept is this. And that's what they were going over on that written part here. So let's go back and see what they have. So let's pause here for a moment. And they say our x value is 2. Remember, we had to put a 2 in there, and we found what our y value was 2. So that gave us the vertex. And they're showing it here in example 4a. And we did that through substitution. Now, as we continue with this example, we want to find now the x-intercepts. We want to find the zeros. So here, y will be 0. And this is not going to factor. So let's go to the whiteboard and solve this by the quadratic formula, which you may recall was x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we need to identify our a, our b, and our c to put it in the quadratic formula. So one of the other techniques is generally you don't want your a value to be negative. So I'm going to multiply everything by a negative 1 and change the signs. So where a would have been a negative, 1, it's now going to be a positive 1. It's just easier to figure that way. B is going to be a negative 4, and C is going to be a negative 1. Okay, so let's substitute. X equals a negative B. Well, B is now a negative 4, so a negative B makes this a positive 4. Plus or minus the square root of. B squared is 16 minus 4. A is now a positive 1. C is now a negative 1. And that's going to be over A, which is 1. 2 times A is 2. So notice here in the discriminant, we have a negative 4 and a negative 1, which will make this all positive. So in summing it up, 4 plus or minus the square root of 4 plus 16 is 20, all over the square root of 2. Now, we could actually simplify this square root of 20 as the square root of 4 times the square root of 5, which would then become, this square root of 20 is going to become 2, the square root of 5. We've simplified the radical, just reviewing that technique a little bit. Square root of 2, or 2, the square root of 5. Now, notice that you could factor out of here a 2. So this is going to be 2, and then this is going to be a 2 here, plus or minus the square root of 5, all over 2. So these 2's cancel out. So simplified, this is 2 plus or minus the square root of 5. And then in the ordered pair would be 2 minus the square root of 5, comma 0, and then 2 plus the square root of 5, comma 0. You have found the zeros. Now, what they're going to do on the slide when we show you is simplifying this into a decimal fraction. This is the exact number, but to put it on the graph, you'll need a value. So let's go back and look at what they've done. And they are not simplifying like we did, but just getting a value of 4.2. And over here, let me clear this up, negative 0.2. Okay, we went a little further. You want to see where it comes from? You have found the zeros. Now, what you want to do is find now the y-intercept. Well, if x is 0, this is 0, this is 0, our y-intercept is going to be 0, negative 1. So this is the easiest ones to find. When x is 0, your y value, this is 0, this is 0, is just going to be a 1. And that's what they have here. Now, they're not asking us to find the axis of symmetry yet, but maybe this next one, yes. They're finally getting to it here. Let's clear that up. So now for graphing the parabola, we have our vertex. We know A was negative, so it opened downward. We have our y-intercept. Let me point that out a little better. There's your y-intercept. There's your x-intercepts. And there they're showing the axis of symmetry is in the vertex, whatever that x value is, that is the axis of symmetry. I'm glad they're getting to it. I think that would be an important part of graphing parabolas. All right, let's go on. And I like it when they give us something we've already done, in a sense, the minimum and the maximum. Remember, if A is negative, your vertex is going to be the maximum. If A is positive, your vertex is going to be the minimum. And that's all they're saying here. And we've done that already. Again, hopefully something easy. Example 5. Just by looking at the equation, would this be a minimum or a maximum, the vertex? Well, notice A is positive, so it's going to be a minimum. Again, they're illustrating that here. Hopefully something easy. Let's go on. Now, obtaining information about a quadratic equation. Consider the quadratic function. We have determined that it's going to be a minimum, and I've written the equation, and I'll go to a whiteboard because how do we find that, in a sense, the vertex? Well, we are going to use the vertex formula, which is negative b over 2a. Well, what is our b value? Our b value is a negative 16. So a negative b would be the opposite of that, in a sense, a positive 16 because of the negative here. Now a is 4. 2 times 4 is 8. Our value will be 2. That will be the x value of the vertex. And they're describing that as the value occurs at x equals 2. Keep in mind that's also the axis of symmetry. Wow. Now we didn't find the y value. We would find the y value by putting in the 2 wherever there's an x, and that's what they're showing you here. So the y value then, and you could write this as an ordered pair, 2, there's your y value, 984. Wow. All right, so again, somewhat daunting, but hopefully in pieces you get to see how it works. I know this is running a little long, but there's lots of stuff here. For example, number 6, they want us to consider this function that we've been looking at. Identify the function's domain and range without graphing. We're going to actually sketch a graph to show you what it would look like and to give you perhaps a visualized view of it. So let's go to a whiteboard here. So we know our parabola's vertex is going to be a minimum, which is right there, and it's going to have this sort of shape. Now, this is just visualizing. We're not physically graphing it and getting all the points, just getting an idea. So what would be the domain, which are the x values, which are these along? So we're going to project this, and then eventually can you see that this would go off in this direction and off in this direction? So our domain is from negative infinity to positive infinity. But our range now, since we know we had a minimum, is going to be a bracket at 984. And then this also continues to go upward here to positive infinity. Okay, so let's just check it out here back in the other thing, and we see that's what we have here. Now they're showing that the range, I believe, should have a bracket here rather than a parenthesis, because this value is included in the set. All right, they could make a little error from time to time. I possibly can too. And we're almost finished. Example 7. these are going to be word problems where we have to figure out, are we using maximum or minimum values? Well, here it says we have 120 feet of fencing to enclose a rectangle. Find the dimensions of the rectangle that maximize the enclosed area. So what will be the maximum of this? Well, we know the perimeter equals 2 lengths plus 2 widths. And we can simplify this as 2L plus 2W and divide everything by 2. This gives us 60 equals L plus W. Now we want to find area, so we need the formula area equals length times width. So if we solve for one of these letters, W, we get 60 minus L equals W. So we can then set up the equation, and I'm going to go to the whiteboard here shortly, that X equals this, 60 minus X. And that gives us the equation now. Stay with me. I'm going to put this to the outside here. Negative X squared plus 60X. I've just got the 60X minus X squared. Put them in standard form. Okay. And we'll go to the whiteboard so you can see it better. Now, what would be the vertex of this? Well, negative B over 2A. What is our A? Our A is 1 here. So negative 60, let's do it this way, negative 60. Our B value is 60, and it's 2A. So this gives us a positive 30. So our dimensions are 30. And if we subtract up over here, 60 minus 30, this is actually 30 as well. So in a sense, our maximum area would be 30 times 30, or 900. All right, let's look at what they have here. And they're showing what we've done. And I'll clear this up here. And there's the answer. So we've done it in a few shorter steps, perhaps, putting it all on one slide. And that wraps up this lesson.